Pydantic AI agents, the framework's core interface for large language models, leverage agent instances to encapsulate instructions, define structured outputs, and integrate external function, tool S for dynamic interaction. The following code demonstrates configuring an agent with a specific output type and depth type, and then defining a tool that utilizes runContext to access dependencies and implements ModelRetry for self-correction during execution.
From Pydantic import base model. From Pydantic AI import agent, runContext, ModelRetry. From fake database import database con. Class chat result base model. Userid, int. Message, str. Agent equals agent. OpenAI, GPT-5 2. Depth type equals database con. Output type equals chat result. At agent, tool retries equals 2. Def get user by name text. Run context database con name, str int. Get a user's ID from their full name. Print name. John Doe. Userid equals ctx. Depth users. Get name equals name. If userid is none, raise ModelRetry. If no user found with name. R. Remember to provide their full name. Return userid. Result equals agent. Run sync. Send a message to John Doe asking for coffee next week. Depth equals database con. Print result, output. User ID equals 123 message equals hello John. Would you be free for coffee sometime next week? Let me know what works for you.
This episode focuses on Pydantic AI's ModelRetry mechanism within agent tools, demonstrating how to implement self-correction logic. An agent is initialized with a specific depth type of database con and an output type of chat result, ensuring type-safe interaction with external resources and structured output. The agent tool decorator registers getUser by name as an LLM callable function, configured with retries equals 2 to allow the model multiple attempts to provide valid input. The getUser by name tool accesses dependencies via ctx, deps, an instance of database con to query a user by name. If the user is not found, it raises a ModelRetry exception, providing a specific message to guide the LLM in its subsequent attempt. This pattern allows the agent to dynamically request clarification or corrected input from the model, enhancing robustness and user experience by preventing immediate failures on invalid tool arguments. The agent runsync method orchestrates the execution, passing the initial prompt and a database con instance as deps. The ModelRetry mechanism enables the agent to engage in a reflective loop, where the LLM's initial incorrect tool call, e.g., John, is corrected based on the ModelRetry message, leading to a successful retry with the full name, John Doe, and ultimately producing a chat result output. Let's break it down.
From Pydantic import base model.
Imports the base model class from the Pydantic library, which is used for defining data models with type hints and validation.
From Pydantic AI import agent, runContext, ModelRetry.
Imports agent, runContext, and ModelRetry from the Pydantic AI library, making these classes available for building AI agents, managing execution context, and handling model retries, respectively.
From fake database import database con.
Imports the database con class from the fake database module, making it available for use in the current file.
Class chat result base model. Userid, int. Message, str.
Defines a Pydantic model named chat result that inherits from base model, specifying that instances of this class will have an integer field userid and a string field message.
Agent equals agent. OpenAI GPT-5 2.
An agent instance is being created and assigned to the variable agent, specifying OpenAI GPT-5 as the model to be used.
At agent, tool retries equals 2. Def get user by name text. Run context database con name, str int. Get a user's ID from their full name. Print name.
Decorates the getUserByName function as a Pydantic AI tool, allowing an agent to call it, and configures it to retry up to 2 times if an error occurs during its execution.
Userit equals ctx, deps users, getName equals name. If userit is none,
retrieves a user ID from the user's dependency within the current run context by searching for a user with the specified name, then checks if the retrieved userid is none.
raise model retry. F no user found with name. R, remember to provide their full name.
Raises a model retry exception, instructing the Pydantic AI model to retry its response generation, and provides a formatted message indicating that no user was found with the specified name and suggesting to provide the full name.
Return userid.
Returns the value currently stored in the userid variable.
Result equals agent, run sync. Send a message to John Doe asking for coffee next week. Deps equals database con.
Calls the runSync method on the agent object, instructing it to process the prompt, send a message to John Doe asking for coffee next week, and providing a database con instance as a dependency for the run.
User ID equals 123 message equals hello John. Would you be free for coffee sometime next week? Let me know what works for you.
A string literal is defined, containing a user ID and a message, which likely represents a conversational input for an AI agent. Pydantic AI agents provide a robust framework for interacting with large language models, enabling structured outputs and dynamic tool integration. The agent instance, configured with deps type and output type, ensures type-safe operations and predictable results. Tools like getUserByName are registered with the agent using the @agent tool decorator, allowing the LLM to call external functions. A key mechanism for enhancing agent reliability is ModelRetry, which allows a tool to signal to the LLM that an attempt was unsuccessful and provide guidance for a corrected retry. This is demonstrated when getUserByName raises ModelRetry if a user isn't found, prompting the LLM to refine its input. The run context object facilitates access to dependencies, such as database con, within these tools. Ultimately, agent runSync orchestrates this entire process, allowing the agent to engage in a self-correction loop, transforming an initial, incomplete tool call into a successful, structured chat result output. This reflective capability, driven by ModelRetry, significantly improves the agent's ability to handle ambiguous or incorrect inputs, leading to more resilient and user-friendly AI applications.
ModelRetry failing. Demands full name agent in its wisdom, then retries.